On a train, the engineer is responsible for proper operation of the locomotive and related equipment. Skilled engineers are essential for the train and its cargo to arrive at their final destination safely. Like the engineer of a train, the wastewater treatment plant operator is responsible for the proper operation of all treatment processes and related equipment at the wastewater treatment plant. Skilled wastewater treatment plant operators are essential for the wastewater to be treated properly before and during the final stage in the treatment process. Usually, the final destination of wastewater within the treatment plant is a process known as disinfection. In the disinfection stage of treatment, it is the treatment plant operator's job to assure effective kill of harmful disease-causing microorganisms known as pathogens. While many microorganisms die off during earlier stages in the treatment process, sufficient quantities of pathogenic organisms may remain and cause health hazards to humans and animals. Therefore, we have this important final stage in the treatment process to kill off the harmful pathogenic organisms. It is important to note that the disinfection process does not kill all living organisms in the water, only the pathogenic organisms. The process that kills all organisms is known as sterilization. Sterilization of wastewater is not the goal of the treatment plant operator. Generally, disinfection requirements are more stringent during the warmer months when activity in the water increases. Refer to your facility NPDES permit for requirements specific to your plant. To gauge the effectiveness of the disinfection process, we use a lab procedure known as the fecal coliform test. Fecal coliform are bacteria that originate in the intestines of warm-blooded animals. While fecal coliform bacteria are generally not considered harmful, their presence indicates the possibility of disease-causing organisms being present. The fecal coliform bacteria are generally hardier than the pathogenic organisms. Therefore, if we kill the coliform, we can assume we have killed the pathogens as well. The three most common types of disinfection processes used in wastewater today include chlorination, ultraviolet light, and ozone. First, let's take a look at the most common agent used for disinfecting wastewater: chlorine. Chlorine may be purchased in many forms, including liquid chlorine, commonly referred to as chlorine gas, is 100% available chlorine shipped in pressurized steel containers in order to keep the chlorine in a liquid state. Examples of containers include 90-ton rail cars, 1-ton containers, or 150-pound cylinders. Sodium hypochlorite, commonly referred to as liquid bleach, is a pale yellow chlorine solution with approximately 15% available chlorine. It is shipped in bulk, or more commonly in 55-gallon drums or 5-gallon buckets. Calcium hypochlorite, commonly referred to as HTH or powdered chlorine, it's a white powder or tablet with approximately 65% available chlorine. It is shipped most commonly in fiber drums or small plastic containers. The form of chlorine you purchase may be influenced by the cost and safety factors. For example, liquid chlorine, most commonly referred to as chlorine gas, is a relatively inexpensive product to purchase per pound. However, the equipment to feed and handle chlorine safely can be quite expensive. Chlorine gas can be deadly if mishandled and is considered an extremely hazardous substance as defined by federal law. Chlorine is one of the chemical elements. Chlorine shipped in containers has both a liquid and a gas phase and is considered a compressed, non-flammable gas by the Department of Transportation. While chlorine is considered a non-flammable gas, it can react violently with many substances to create a fire, especially petroleum distillates. When chlorine comes in contact with moisture, it also becomes highly corrosive. In the liquid state, chlorine is amber in color and about 1½ times heavier than water, and it boils at 30 degrees below zero. When vaporized, 1 volume of liquid chlorine will produce approximately 460 volumes of gas. Chlorine gas has a characteristic pungent odor and is greenish-yellow in color. Chlorine gas is approximately 2½ times heavier than air. In the event of a leak, chlorine will seek the lowest level. In most cases, wastewater treatment plants use chlorine gas that vaporizes from liquid chlorine within a container. For example, on a 1-ton container, we position the valves straight up and down and hook up to the top valve to get the chlorine gas. Facilities handling liquid chlorine or chlorine gas must be prepared to deal with a chlorine emergency. There are state and federal laws that have planning and reporting requirements that must be met. Failure to comply with state and federal laws can result in stiff penalties. The federal law requirements are listed under SARA Title III, while the state requirements are covered under Pennsylvania Act 165. For more information on how to comply, contact your county emergency management agency or the Pennsylvania Emergency Management Agency. If handling chlorine at your site is a necessity, you can cut the risk of handling chlorine through prevention. The best way to deal with a chlorine leak is not to have one in the first place. Use of vacuum tubing in a chlorine gas system can cut down the likelihood of a leak. Most chlorine leaks occur when containers or cylinders are being changed. Strict procedures for handling chlorine by trained personnel with proper equipment can cut the likelihood of a leak. If a leak should occur, early warning, emergency pre-planning, and training can reduce the damage caused by a leak. Chlorine gas leak detection equipment should monitor all chlorine handling areas. Leak detection equipment should be tied into an alarm system that notifies the facility of a leak during or after hours. Windsock or wind speed direction indicators will give workers on and off site an idea as to where the vapor cloud is going in the event of a leak. Chlorine scrubbers or vapor suppression systems can help to knock down chlorine vapors and prevent them from leaving the site. A self-contained breathing apparatus with proper protective clothing is a must for handling a chlorine leak. Never work on a chlorine leak alone. A chlorine emergency repair kit for the appropriate container should be readily accessible. It is plain to see that handling liquid chlorine can be dangerous and requires skilled, knowledgeable operators to handle it properly. Facilities that use small quantities of chlorine may elect to purchase chlorine in a less hazardous form, such as sodium hypochlorite or calcium hypochlorite. The feed and safety equipment for sodium hypochlorite or calcium hypochlorite is fairly inexpensive, while the per-pound cost of chlorine is more than if you purchase the product as a gas. Neither sodium hypochlorite or calcium hypochlorite is considered an extremely hazardous substance. While sodium hypochlorite and calcium hypochlorite are generally safer to handle, they are chemical products that must be treated with respect. Make sure you are familiar with the MSDS for a product before you work with it. Mixing products or careless handling can result in accidents such as fires or chemical burns. For example, the MSDS for calcium hypochlorite, or HTH, says that if the product mixes with petroleum distillates, a fire may result. You would not want to store HTH in a garage next to the brake fluid or other non-compatible products. Regardless of the form of chlorine you use, your main objective is to kill the pathogenic organisms in the wastewater in accordance with your NPDES permit. Remember, chlorine in excess quantities can be considered a pollutant as well. When adjusting chlorine feed rates, you should add just enough product to get the job done. Too much chlorine can kill aquatic life in a stream. Depending on your location, removal of residual chlorine from your effluent may be required as well. Chlorine is a powerful oxidant that may be consumed when we add it into our wastewater. In order to get an effective kill of pathogenic organisms, we must satisfy the chlorine demand and achieve a chlorine residual. You may measure chlorine residual in wastewater as free chlorine, combined chlorine, or total chlorine. Most commonly, we measure for total chlorine residual in wastewater treatment plants. The most effective form of chlorine for disinfection is free chlorine. Combined chlorine is chlorine that is combined with ammonia or nitrogenous compounds. Combined chlorine is generally less effective for disinfection purposes. Combined chlorine residual is calculated by subtracting the free chlorine from the total chlorine. There are several factors that influence the effectiveness of the chlorine process. Detention time is an important factor. Generally, the more contact time we have, the better disinfection will work. The effectiveness of upstream treatment units can play a role. The cleaner the wastewater, the more effective the chlorine will be. The pH of the wastewater also has an impact. The lower the pH, the more effective the chlorine will be. Temperature also has an effect. Disinfection works better at higher temperatures. It is important for the operator to maintain all chlorination equipment in peak operating condition in order to ensure proper disinfection of the effluent and to protect lives. This includes regular maintenance of chlorination equipment, dewatering, and removing solids from chlorine contact chambers. Now that we have taken a look at the use of chlorine for disinfection, let's look at another alternative for disinfecting wastewater: ultraviolet light. Ultraviolet disinfection utilizes special electrically powered lights that generate ultraviolet light. It is the ultraviolet light that kills the pathogenic organisms. In an ultraviolet light system, there may be several rows or banks of light tubes that turn on and off in accordance with the facility flow. In order for the ultraviolet light system to be effective, the wastewater entering the ultraviolet disinfection system must be very clear. It is important for the operators to keep ultraviolet light tubes clean and to replace ultraviolet light lamps when they burn out. A regular schedule for inspecting, cleaning, and replacing of lamps should be established. One of the nice features of ultraviolet light is that there are no harmful residuals left in the wastewater and no chemicals to feed. However, we do have the special electrical control equipment and the power costs to light the tubes. As with the chlorination disinfection process, skilled operators are needed to maintain and properly operate an ultraviolet disinfection system. Now, another type of disinfectant is ozone. Ozone is a powerful oxidizer and an extremely effective disinfectant. However, ozone is usually generated on site, and the generation equipment can be quite expensive to operate and maintain. As with chlorine and ultraviolet disinfection, ozone requires highly skilled operators to properly operate and maintain the system. And only now, after the wastewater has been properly treated and disinfected, can it be released back into our water environment, clean, safe, and ready to be used by the next downstream user in full compliance with NPDES permit conditions. Remember, we all live downstream.